in which all atoms are in first excited state. Here a radiation is incident. So 12.5 electron volt, when it is incident, to what transition will it correspond for? I think we have to check it. So minimum how much needed? 10.2. So what will happen to this hydrogen gas? Minimum needed 10.2. So can it make a transition to IS state? 12.5, will it correspond to any IS state?
More than second.
Not possible. I think it cannot excite to any IS state. Am I right? Look at 12.5. N equal to 1 to N equal to 10.2 is needed. Then you check it from N equal to 1 to 3, N equal to 1 to 3, 1 to 2, 1 to 3, 1 to 4. Okay, this particular photon will not correspond for any of the transition. So therefore, this hydrogen atom will not absorb this radiation. Okay, then let's not think about will it pass through it or not. Okay, I'll give it in this way. A very simple idea. So therefore, what will happen to this particular thing? Will not absorb. So it will just pass out as if. So what will happen to hydrogen gas? Will remain. Means can it happen? Sir, how much needed? 10.2 is needed. Of 12.5, it will absorb partially. Then remaining, it will reject. No, not possible. So the hydrogen atom will absorb only the photon which is required for its transition. Anything less than or greater than will not absorb. This is a golden statement which you have to remember. That's all. Because we do take problems where exactly equal to that the difference energy levels. But if it comes more than or less, it will not absorb. Next, what happens to the hydrogen atom? It will excite to ground state and it will give out. It will give out a photon of how much? 10.2 electron volt. Photons here. Photons emitted due to de-excitation. Is that okay? They're not absorbed, not absorbed. Sample A, no, the sample A, sample B. Not absorbed by sample A. This is simplest thing. Okay, no. They is telling the atoms of sample A after passing of light through it, maybe in first excited state, maybe in second excited state, maybe in both first and second, none of this. I'll pick up option, none of this. The emission spectra of sample A. Must have 3 lines, 2 lines, it is not formed. The atoms of sample B will ionize when emission spectra of A is incident on B. May ionize when emission spectra of A is incident on B. Will excite to some ionized state but won't ionize. None of this. None of this, no. Okay, now part 2. Repeat the above 3 questions if instead of beam of light, beam of neutrons passed through atomic hydrogen gas. This one. Same thing. Now what can result? Beam of neutrons, how much of energy? 12.5. Neutron beam. This is a hydrogen atom. N equal to 1. This is a sample B. What can happen now? Yes, now what is need? How much needed? It will absorb from neutron beam. So 1 neutron will interact with hydrogen atom where it will give 10.2 electron volt. 1 neutron will interact with hydrogen atom where it may send it to higher state also. Anybody possible? Any higher state?
Second state possible. Second excited state possible.
Second exit is possible. Okay, then we'll do one thing. N equal to 1, 2, and 3. So N equal to 3 also possible.
Yes, sir.
Yeah, then what happen? We'll get a photons. This is one photon. This is another photon. So these are the 3 photons. What happen will be available. So when they are falling on the hydrogen atoms of sample B, anything can happen. Okay, this will be, I'll write down vertical lines. I'll put it. This is the possibility. Yeah, this will be lambda 32, lambda 21, lambda 31. Okay, when these photons, if they go and strike the sample in hydrogen B, I think any possibility after this. So what all can absorb this? N equal to 2, no? It may get ionized. Any photon can ionize it. Okay, I think it's possible, no? If this photon is incident, the B weapon can jump from N equal to 2 to 3. If this 3-1,
3-1 it will possible.
3-2 and 3-1 are possible.
3-1 and 2-1.
3-1 and 2-1. No, it is already there in first excited state, no? If this photon strikes, it will jump to 3. And from 3 to 1, it can liberate. So here, the spectrum will be like this. This is the permit. This is what it is existing. So if it absorbs lambda 3-2, it may jump. Okay. Then again, it will give out lambda 3.
Can ionize also.
It can ionize also.
Sir, for 3-1 and 2-1.
Lambda 3-1, lambda 2-1 for both it can ionize.
Lambda 2-1 and lambda 3-1, it can ionize. Oh. Okay, again, lambda 3-1, if it falls on this, it'll get ionized. So all 3 it will absorb.
Not necessary.
So n equal to this lambda 32, it will jump to excited state. Again, if it absorbs lambda 31, it'll get ionized. If it absorbs lambda 21, ionized. Okay, there are I think two possibilities are there. It'll get ionized or get excited. Am I right? I'll put it sample B. Few atoms get and can we write this commit? Few will get ionized, few will get excited. I think all will get excited, will get ionized. It seems like this. Okay, first it will get, yeah. Okay, let's write statement.
Without excitation also directly it can ionize, sir, from n equal to 2 to infinity directly.
Okay, this one. Sample B, few atoms get ionized and few gets, all will get ionized or only few will get ionized? Okay, probability. It is
All hydrogen atoms will not emit. All hydrogen atoms in the second case will not absorb news.
no, if lambda 32, it will get, okay, this one. Okay, that if this falls, it may get ionized from here. If this hydrogen sample B, if it is here and absorb this, it will get ionized. For this, it will get excited. Okay, I think I'll write it. No, few. I think I should write it.
Sir.
Few I should write it. Few or all?
Few, sir, we cannot say all.
Few. Okay, better few only. It's also, I think, from textbook only. I just picked up. Nice problem. The photon and neutron, the idea is totally different. They're the very fundamental one. Please revise such small basic ideas, because